Remember that?
Also, the way that's the diagram.
It's not asking you to draw orbitals. Okay? If it says draw the orbitals, then you would draw the orbitals. However, it would be very cruel for them to say draw these orbitals. Electron configuration for silicon.
From what I heard in the video, you have to take like the element that you're using and then go one row up and use the halogen to replace the first few, like not replace, like, yeah. No, the noble gases, sorry. So you have to basically, instead of writing the whole thing out, you would just use the noble gases to replace part of the electron configuration, and then so you would use neon because that's one row above, and then you would be left with 3s2 and 3p2.
Okay. What is the electron configuration for neon? Caitlin.
1s squared, 2s squared, 2p6.
There you go. So instead of writing that out, you replace it with a noble gas that is identified by that part of your electron configuration. So it would be silicon, colon, neon, 3s2, 3p2. Yeah.
So in the video yesterday, all of the examples that you gave to us to figure out, in a shortcut form, there's always two terms after the noble gas. Is that a pattern that always happens, or
No.
You can be more?
Yeah. Yeah.
So when an atom becomes a cation and some electrons are removed, like there's less electrons. If let's say the highest quantum number, what is it, the 4s2, then that's the highest, because you have to remove from the highest principal quantum number, you remove the electrons from there first.
Yeah.
If they're already removed from there, then what's the next thing?
Whatever's the next highest.
With the highest energy?
Well, if you've already gone through all your 4s and you're only left with 3s, which one's higher?
If you see a 3D, then
3D is the next highest one.
and
What's below the 3Ds?
There's the 3F. I mean, sorry, not F, there's a 3P.
Yeah.
Yeah. And is there any other exceptions except chromium and copper?
Yep. We will. Okay. Draw for me the electron configuration for manganese. Right? I'll use my target. These two leave first because 4 is bigger than 3. 4 is bigger than 3. You learned that in kindergarten. What comes next? 5. 5 is bigger than 4. So if you have a 5 something, it's going to go from there first. You pick out of the highest principal quantum number first. Now, manganese is interesting because it can also form other ions. We can lose these We can lose these and be a 5 plus. We can lose all of them and be a 7 plus. But when I ask you, what is the most likely ion, you're going to pick from the highest principal quantum number first. Now the thing about d orbitals, no, I'll get to that. What do you think will be the most common ion for phosphorus? Is you would do P3 minus and then 3s2 3p6. Those extra 3 electrons went into p orbitals. Right? Put your finger on phosphorus. It gains 3, so move your finger over 3 spots. Where do you end up? Okay, when you are a negative ion, you will become isoelectronic with a noble gas. You will become isoelectronic with a noble gas. What does that mean? It means it has the same number of electrons, therefore the same electron configuration. I'm going to be asking you questions on quizzes or assignments or tests. I'm going to ask you whether or not they're isoelectronic. Or I'll say to you, identify the atom or ion. But you won't know anything other than the electron configuration. I could have said, you've got X3 minus, neon, 3s2 3p6, or I could have said you've got Z1 minus, neon, 3s2 3p6. What's the difference? Are these the same element? No. I used a different letter, but I also used a different number of electrons. They are isoelectronic, so they are isoelectronic with argon. But X gained 3 to get there, so count back 3 from argon. Phosphorus. This gained 1, so count 1 back. There you go. So therefore, this is phosphorus 3 minus, and this is chlorine 1 minus. Don't tell me it's chlorine, because it's not chlorine. It's the chloride ion, right? Start with the bottom is the lowest. You go up and line up the S's, the P's, and the D's. Okay? So how many electrons does iron have? 26. Okay, put down your pens and watch. If I can write. $26. That was weird. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What do you notice I'm doing?
You're first putting one on each orbital in the suborbital before putting them on.
Yes. Now I've lost my count. 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. What are the two charges for iron that you remember from last year? 2 and 3. And guess what? Now you're going to see why. Now you're going to know why. If you lose from the highest principal quantum number first, 4p is there but it has no electrons. It's still there, but you can't lose electrons from it because there's none in it. So my highest principal quantum number then is my 4s. So I can lose those two. Right? If I lose those two, I am now Fe2 plus. But this is the thing. So a half-filled d orbital is more stable because it's lower in energy. So that's why we lose that third electron. Okay? So for these kinds of questions, I strongly suggest you do the electron configuration for the atom first. And then start removing your electrons. So 5p is higher in energy than 5s, so you lose from there first. Did everybody else have this?
Wait, I'm confused with copper because doesn't copper have, it has 29 electrons?
Well, look where it is on the periodic table. 1.
The D.
So what did you tell me? Did you say 3D9 or 3D8? Should it be 3D8 or 3D9? Yeah. Okay, so you're counting over. If you get stuck, count over boxes. Okay? Okay, but these are actually incorrect. You did them correctly based on your information, based on the knowledge that you gained yesterday. What did I say earlier about a half-filled d orbital? It's very stable. What about, oh, I didn't say anything, I think, about the full, right? Okay, so a half-filled d orbital is very stable, so is a full. So what happens is, if they are only one, hear that number? 1 electron away from being a half-filled or full-filled, they will take an electron from the s orbital. So copper will take an electron from the s orbital and promote it to the d orbital. Sorry, that's a 10 at the end. Oh, you wait till I make you come up and write with this stylus. Therefore, chromium would be argon 4s1 3d5. Okay? All right. Are you okay with this? It happens for every element below chromium and below copper. You will borrow from the S, put it in the D. Does that make the atom excited? No. It just borrowed. Does it make it an ion? No. Because we didn't gain or lose, we just shifted them around. What charge did I tell you last year silver always has? Mark it on your periodic table, I said. 1 plus. Do the electron configuration for silver.